What if I told you that you've probably used like a dozen computers already this morning, and you haven't even touched your laptop or phone? I'm talking about the hidden ones, the invisible intelligence that's packed into your car, your washing machine, even the traffic lights on your street. These little powerhouses are literally everywhere, quietly running our world behind the scenes. So let's pull back that curtain, shall we? Let's dive into the incredible, invisible world of embedded systems. All right, so here's what we're going to cover. First, we'll get a sense of just how massive this hidden computer invasion really is. Then, we're going to nail down the big question, what is an embedded system? After that, we'll peek under the hood at its architecture, see them in action in the real world, and figure out what makes them so different from, say, your desktop computer. And to wrap it all up, we'll take a look at what's coming next. Okay, let's jump right in. The first thing you need to grasp is just how widespread these systems have become. They're not just simple little helpers in the background anymore. They've evolved into the brains behind, well, pretty much our entire modern world. So to really get a sense of the scale we're talking about, let me ask you something. Just picture a modern car, right? Think about all the tech packed in there, the safety features, the big touch screen, the engine controls. Now, take a guess. How many computers do you think are actually running all that stuff? Ready for this? The answer is often over 100. Yeah, you heard that right. Over 100. Your car is basically a super high-tech, rolling network of tiny, specialized computers. They're managing everything, from the engine and the brakes, all the way to your Spotify playlist. And look, this isn't just about cars. It's so much bigger. That idea of a network inside the car, that's the perfect way to think about our whole society. These systems are, and this is a great way to put it, the digital nervous system of our world. They're constantly sensing, reacting, and controlling all the machinery that keeps things moving, from a factory floor to the power grid that lights up our cities. Okay, so that brings us to the million-dollar question, right? What exactly is an embedded system? Let's get a clear definition. Okay, here it is in a nutshell. An embedded system is basically a computer, but with a very specific mission. It's a tight combination of hardware and software that is designed to do one dedicated job and do it really well. Think about it. Your laptop can do a million things, right? It's a generalist. An embedded system, on the other hand, is a specialist. It's a master of one. Its only job might be to control the anti-lock brakes in your car or manage the temperature in your smart thermostat. It is purpose-built, and honestly, that's its superpower. All right, so how do these things actually do what they do? How do they perceive the world around them, think about it, and then act? Well, it really all comes down to a pretty straightforward three-layer architecture. First, you've got the sensing layer. This is how the system sees or feels the physical world. It uses all kinds of sensors, cameras, microphones, you name it, to gather data. Next up is the processing layer. This is the brain of the whole operation. This is where powerful little processors analyze all that data, and they do it in real time. You'll often hear this called edge computing, and all that means is that the thinking happens right there on the device, at the edge of the network, which is way faster than sending everything to the cloud and back. And finally, you have the communication layer. This is what sends the final message out, whether that's a command to another part of the system or an alert to you. And, this quote about cars just nails it. It really brings that whole architecture to life. You have the big, central computer acting as the brain, making the high-level decisions. But then you have all those smaller smart modules, the sensors, the communication chips. They act like the nervous system. They're feeding information to the brain and then carrying out its commands. It's just a perfect way to visualize how all these layers work together. Okay, so we've got the what and the how down. But where are these things really making a difference? Let's look at some real-world examples that you probably interact with every single day. Okay, think about your car. They're powering those advanced driver assistance systems that keep us safe. Now picture a factory. They're using AI to predict when a piece of equipment is about to break, saving a ton of money and time. Back at home, they're running the brains of your smart TV and making your washing machine way more energy efficient. And then zoom out to the whole city. They're in smart energy meters, optimizing the power grid in real time. So yeah, safety, industry, entertainment, sustainability, they are the invisible engine behind it all. Now, this is a really important point. It's easy to hear computer and just think of the laptop you're using, but an embedded system is a completely different animal. So what exactly makes them so different? Well, it all comes down to specialization. Your PC is a generalist. It can run thousands of different apps. An embedded system is a specialist. It does one thing and one thing only. And because of that, it has to live with some pretty tight constraints. We're talking very little memory, just enough processing power, and it has to be crazy energy efficient, especially if it's running on a battery. But that laser focus is what makes them so cheap to produce by the millions, which lets them become just one small, inexpensive part of a much bigger device. So these systems have already come an incredibly long way, right? But the crazy thing is, the real innovation is just getting started. So for our final section, let's look ahead and see what's coming next. I mean, just think about this progression. Back in the 80s, an embedded system was basically a simple controller in, say, a washing machine. Fast forward to today, and now we're talking about AI-enabled devices that make intelligent decisions all on their own. And when you look even further out, with things like 6G networks on the horizon, the network itself could become a sensor. We're talking about our entire communication infrastructure acting as one giant embedded system. And there are a few huge trends that are really pushing this forward. You've got things like RISC-V, which is an open standard architecture. That just means it's way cheaper and easier for anyone to design custom processors for their specific needs. Then there's this wild idea of digital twins. These are exact virtual replicas of physical systems that let us simulate and predict problems before they even happen. And of course, security is getting a massive boost. We're seeing AI right on the device that can detect threats in real time, and even brand new cryptography to protect these systems from quantum computers down the road. And all of this brings us to one final, really big thought. The evolution here is just undeniable. These systems are truly becoming the nervous system for our entire world. So the really critical question we all have to ask ourselves is, as we build this thing, how do we make sure it's not just smart? How do we guarantee that this global nervous system is also safe, secure, and sustainable for the future we all have to share?